So we're going to calculate the volume and surface area of both these cylinders. That's just mechanical, you just learn it. You have to learn the formulas, you work out how to do it. So that's only really E points. The important part of this question is compare and discuss. Okay? So what do? Well, we know the formula for the volume of a cylinder, VA equals pi r squared times h. I've suddenly put letters in here, and these letters aren't defined anywhere, so that isn't okay. So I have to tell you that VA is the volume of cylinder A. You can actually just say V is the volume, A is for cylinder A, and B is for cylinder B. Then I don't have to write volume twice. Mathematicians are a bit lazy. R is the radius. H is the perpendicular height. And we're also going to work out the surface area, which I'll define as being SA. So before I do put any numbers in my question, I make sure I've summarised the question, drawn a sketch, defined all the terms I'm going to use, and now I can start putting numbers in. And I hope this is what it looks like in your books too. And we were to assume that pi was approximately 3 for this question. So we just now can punch in the numbers. 3 times 5 squared times 10. So volume A is going to be 3 times 25 times 10, which is going to be the same as 3 times 250, which is going to be 750 centimetres cubed. And it's actually quite good here if you put the units in as well. Here you've got centimetres squared the whole way through, just so that you're sure you've got your centimetres cubed that you want. So the volume of cylinder A is 750 centimetres cubed. Volume of cylinder B then, same formula, pi r b squared times h. 3 times 10 centimetres squared times 5 centimetres is going to give us 3 times 100 centimetres squared times 5 centimetres. 3 5s are 15. 15 times 100 centimetres cubed is going to give us 1,500 centimetres cubed. So the volume of cylinder B is actually double cylinder A. We would expect that. I mean, it's a lot wider, even though it's shorter. That's going to give us a lot more volume. So that's really not interesting. It gets interesting when we actually have calculated the surface area. So if we look at the surface area, the formula for surface area is we've got to add the area of the top ring and the area of the bottom ring. So we're going to have 2 times pi r a squared plus the area going around the outside of the cylinder, which we know is pi times the diameter, which the diameter is 2 times the radius, because we haven't used d here, multiplied by the vertical height. If we were to stretch this out, we'd get a rectangle where the height would be 10 centimetres and the length at the top of the rectangle would be pi times the diameter, or pi times 2r, because that's what the outside of the top of the cylinder is. So we'd have that as our rectangular area. So if we start to plug the numbers in here then, we get 2 times 3 times 5 squared plus 3 times 2r, which is 10, times the height, which is 10. So here we get 25 times 6. Here we've got centimetres squared. Here we've got centimetres times centimetres. Checking that we've got the right units here. Here we're going to get centimetres squared. Here we have centimetres squared. So 6 times 25 centimetres squared plus 300 centimetres squared. 2 5s are 50, so we're going to get 150 here. Just check, 6 5s 30, 6 2s 12 plus 3 15. So we're going to get 150 centimetres squared plus 300 centimetres squared, giving us 450 centimetres squared. So the surface area of cylinder A ends up being 450 centimetres squared. Same thing again for cylinder B. SA of cylinder B is going to be 2 times the area at the top and the area at the bottom, pi the radius B squared plus pi times twice the radius times the vertical height. Plug our numbers in here now. Once we put the formula in, we get 2 times 3. The radius here was 10 centimetres, so we get 10 centimetres squared plus 3 times, the radius was 10, so the diameter is 20, times 5 centimetres was just the height. So here we get 6 times 100 plus 20 times 5 is 100, 300 centimetres squared here. And that's going to give us 600 plus 300, 900 centimetres squared. So the surface area of B is going to end up to be 900 centimetres squared. Now comes the interesting bit. I've asked you to discuss and compare these two cylinders. But what we're interested in then is which one gives us the largest volume for the smallest surface area. The surface area would be if we had to manufacture this cylinder out of metal, for example. Maybe it's some sort of deciliter measurement or something like that. We'd need to use a certain amount of metal. And to know how much metal we'd have to use to get the same volume, I'd like to know which of these two cylinders is most effective, which uses the smallest amount to manufacture, but it actually gives me the largest volume. Well, what we can do then is we can actually divide the volume by the surface area and get a ratio for both of them and see which of them has the highest volume to surface area ratio. So if we were to divide the volume of cylinder A by the surface area of cylinder A, we'll get a ratio here of the amount of metal we use for the amount of volume that we'd get inside. So if we were to do that, we'd get 750 divided by 450, cancel the zeros and divide top and bottom by 5, because that's a nice easy one to do, isn't it? 5's go into 7 one time, 2 left over. 5's go into 25 5 times. On the bottom, 45 divided by 5 is 9. We can now divide again by 3, because top and bottom divide by 3. So we get 15 divided by 3 is 5, 9 divided by... So the ratio of the amount of volume we get 5 centimetres cubed of volume for every 3 centimetres squared of area we use. Right, let's look and see what we get for cylinder B then. Well, volume B divided by the surface area of B would give us 1,500 divided by 900. Oh, look, we get 15 over 9 straight away. Isn't that what we got there? Yeah, so the ratio of volume to surface area is identical for both of them. Both of those cylinders, even though they had very different shapes, would give us 5 centimetres cubed of volume for only using 3 centimetres squared of material to make them. And that would be your discussion here, that these cylinders are just as effective in volume to surface area ratio. And that would be an excellent discussion that you could have in your books.